Now I'd like to talk about the problem of charging a capacitor with another capacitor. And this is sample problem 25.03 in your book. What happens is you are given a capacitor C1 which has a capacitance of 3.55 microfarads. And then you hook a battery across it, that's this thing here, along with a switch. So the battery has a voltage of 6.3 volts. So get this circuit in your notes. Now what happens is you're going to close the switch. What will happen? So if I do this by closing the switch, basically now current can flow and will continue to flow until the capacitor is fully charged. So ultimately V0, a potential difference of V0 will develop across the capacitor, at which point the current stops, and then we want to figure out what's the charge on the capacitor. And from the drawing you can see that the top plate has to have some kind of charge Q0 and the bottom will have charge minus Q0. So to figure out the charge on the capacitor, you use the capacitor formula Q0 equals C1 V0. And we know what C1 is, and we are also given V0, so we can figure out the charge on the capacitor. Okay, the next step in the process is to disconnect the battery. So you literally pull off the battery from the circuit, and then you just break it open over here and here. And then you're left with just a plain old capacitor like this. And when you just pull the battery off, you're not removing the charge from the capacitor. So it still has a plus Q0 on the top plate and minus Q0 on the bottom plate. And then you haven't affected the voltage across the plate because your charge has remained the same and your capacitance has remained the same. So you still have V0 across the capacitor. The next stage in the process is to attach an uncharged capacitor C2 across C1 with a switch. So think about what that could mean. So you have your C1 like so, and then what you're going to do is attach another capacitor to it. Now your C1 is charged originally, so it's like this. But now you're going to attach another capacitor, C2, that has zero charge on it. And then you want to hook it across C1 with a switch. So this is what that statement, attach uncharged C2 across C1, means. So it looks like this. And this system is very happy the way it is. So on the left-hand side you've got a voltage V0, and on the right-hand side you have 0 volts, 0 charge, and 0 volts. The next stage in this process is to close the switch. So here is the original circuit with Q0 on the upper plate of capacitor 1, and what you're going to do is close the switch like this. And now when you close this switch, you've got a complete circuit. So now what happens is Q0, or some of Q0, can flow this way and flow this way, so that you no longer have 0 coulombs on this plate and you no longer have Q0 on this plate. And similarly, charge can flow this way so that you no longer have minus Q0 over there. And the question is exactly how much charge will there be on the plates after this process is finished, and what is the voltage across the plates? Okay, so the way to look at it is the following. After the switch is closed, you've got a new amount of charge on C1, Q1 here, and then a certain amount of charge on C2, Q2. But the thing that's the same for both capacitors is the branch voltage, or the voltage drop across the capacitors. And I've labeled that voltage drop as being V prime, like so. Now you can write an equation relating C1, Q1, and V prime, namely this one, And then you have a similar equation for C2. Now the thing is, you have to combine these two equations. So originally there was Q naught on C1, and that Q naught has now been spread onto two capacitors. So you have a Q naught that now equals Q1 plus Q2. So we can plug in for Q1 and Q2 like this. We know the value of Q naught. We know the value of C1 and C2, so therefore we can figure out V prime. So let me first factor out V prime from here. And then we know that V prime equals Q naught over C1 plus C2. And then from before, Q naught equaled 22.365 microcoulombs. Again, don't stick the micro into your calculator too soon. And then the C1 is 3.55 microfarads plus C2, which is 8.95 microfarads. And then what's really nice is that you see that the micros cancel each other. So you have 22.365 in the numerator, and you have 12.60 farads in the denominator. So when you plug it into a calculator, you get V prime equals 1.79 volts. And you can see this value is lower than the original 6.3 volts. And that is because the charge was redistributed across two capacitors. And then once you have V prime, you can figure out what Q1 and Q2 are. So Q1 is C1 V prime. So now that's 3.55 microfarads times by 1.79 volts. You can figure that number out. And then Q2 is also something you can calculate. So it'll be this. And we are done with this problem.